Welcome back to Operational Technology Security. In this module, we'll discuss the differences between IT and OT security. It is very important to understand the difference between the two because different approaches are taken when we discuss IT and different approaches should be taken when we discuss OT security. For example, think about, in our regular computers, everybody should have some kind of antivirus, right? So you may have the Windows one, or you may have Norton antivirus. You have some form of malware detection. But on a PLC, on an industrial device, it's not straightforward to install a malware detection system because of some constraints. For example, it may interfere with the real-time requirements. I will see later today. It may not, the processor and the memory may not be enough because the PLCs were not designed to support antivirus, right? An antivirus system, it's designed to support the process and the control, and it's only doing that. So it may not be able to support the software, any intrusion detection system or others. Another prominent example we'll see later also is rebooting. You want to, you have your machine, your phone, it says a new update is available, you have to restart your computer. Everybody's kind of upset and annoyed that you have to, but at some point you do it, right? But this is not the case in OT. If you have a security patch, you cannot just restart the PLC. You have to have a proper process for shutting down if it's a plant, right? You cannot just stop it and restart it. You have to have a proper process for outage control that you start your maintenance in a week from now, in a month from now. If it's in a power grid, you try to make sure that you don't interfere with the functionality of the city. So things we do in the IT world cannot be directly applied to the OT. And today we'll see detailed examples and requirements of this. So the handbook, the NIST handbook, has a detailed list of these. We'll see all of them, differences. There are more than this, but this is what we'll focus on today. So let's start. The first one is timeliness and performance requirements. In the IT world, we don't have a real-time response or operating system. A real-time operating system is a different flavor of an operating system. We're not used to them when we have, again, our computers, our phones, our operating system, our Windows, Linux, Mac OS are non-real-time. Right? They will respond at some time, but think when you're starting a program like your browser, Chrome, one time will take 1 second, maybe the next time will take 0.5 seconds, some other time may take 5 seconds if you have other programs running, right? So in a way, you don't have a guarantee about when the process will be executed, the operating system process. In the OT, you have guarantees, right? Because in the operational technology environment, you're controlling a physical process. You have to ensure if something runs and has to be controlled every 1 millisecond, you have to ensure you control the response within 1 millisecond. So in the IT world, it's non-real time. The response must be consistent. When you start a program, you expect the program to start, and that's it. You don't expect things not happening. You worry about high throughput. You want your computer to be fast, to be doing as many things as possible. And if sometimes something takes 1 second, the next time it takes 3 seconds, you may be slightly upset, but it's acceptable, right? You understand the delay and jitter is acceptable in IT, in regular computers. And the interaction is less critical, as you can also read in the slide. You don't control something that can endanger human lives. It's your email, you may be playing a game. So if your computer freezes, if you have a blue screen of death, then you just start and life goes on. So this is in the IT side, right? In the OT, as I said before, the operating systems are real-time. That means when the process runs, there are deadlines that the process has to be executed, and there are guarantees that the process will be executed within the time frame. And the operating systems that are real-time have algorithms that ensure that the real-time requirements are not violated. There's algorithms like earliest deadline first, that you prioritize the processes, and then the one that should be completed sooner is the one that gets scheduled first, and then the rest follow. So it's real time. The response is time critical. If you're controlling a process and you have to respond, open the valve within 1 millisecond, you have to open a valve within 1 millisecond. Otherwise, you may have mechanical damage or other effects. So you have to make sure the response is on time. Throughput is not. It's not really a big deal, right? You don't care about many things happening. You just want a few things happening, but definitely happening, that they take place at the time they should. The systems, so there's delay and jitter is not acceptable. You cannot have a valve responding, sometimes in a second, sometimes in half a second. It has to respond exactly as specified according to specifications. So high delay and jitter is not acceptable. And the response to human is critical. If something goes wrong, you shouldn't be standing in front of a frozen HMI or a frozen computer and wait for something to be loaded, right? Your response the operator may need to do something within seconds of an incident. So you cannot wait for things to boot or start. The response is critical. As an example of the difference between IT and OT in terms of timeless requirements, think of a deep packet inspection system that you have. Your device is connected to the network, there are packets coming in, and you install some kind of a system that inspects the packets and try to understand whether there's malware there. But the inspection of the packets is slowing down the communication. It takes time, so to actually see and make a decision about what's happening. So if you send a command to the PLC and you expect it to respond within 1 millisecond, adding this intrusion detection system in front, the deep packet inspection system, it may increase the delay to a response of 2 or 3 milliseconds or a certain time. So you cannot do it. In IT, you could have done it because 1 or 2 milliseconds is not very different. In OT, you cannot do that. So that's not a solution you can apply. You have to think of other ways, right? Instead of deep packet inspection in the control environment, probably a better solution would be to ensure in the boundary that the periphery is secure, right? That the malware will not go into the control network, so you won't have to do further action in detecting with deep packet inspection, right? You can do maybe other things, but that's an example of what should be avoided in the OT side. Next, we have availability requirements. That's also very important. IT, I mentioned in the introduction of this video, we're kind of used to rebooting, right? And it's becoming frequent with all the security updates we've been getting. Many vulnerabilities have been discovered daily. So we've been getting messages from the operating system, sometimes from applications, that they have to install a new version, so you have to install. And restarting an application may not be as annoying as restarting an operating system. So, but if you restart, right, you can plan it, you can do it overnight when you're sleeping, or you can do it sometime when you're taking a break. So nowadays Windows is asking, can I plan it when it's convenient for you, or automatically do it, because the companies realize that humans would never actually restart. So they change the policy of asking to actually enforcing the restart to happen. So we will say, but they're trying to reduce the inconvenience. They'll say, we'll restart overnight unless you want to restart now. So they take a different approach nowadays, that they restart anyway without asking you, but they give you the option to do it now or to do it at a time that the operating system thinks it's convenient. This interaction we're used to in the IT world, right? We're expected to restart. In the past, we're starting for performance, to refresh the computer. Nowadays, we're starting for mostly updating and for patches. In the OT side, it should be very clear that rebooting is not an acceptable process. So we saw desalination earlier in this class. You cannot stop the flow of water and stop the output of the process, the potable water and the brine coming out, because you want to restart the PLC.
So in that context, you have to think of other ways of applying, for example, security patches, right? The vendors may get back to you and say you have to install the new patch because the PLC has a vulnerability, it has a buffer overflow, or a malformed packet can cause some kind of behavior that someone can overtake the PLC. In that context, you have to think of ways of how to patch, and patching actually is a very difficult problem in the industry, how you apply patches. Because even for example, you could not apply patches, right? If you think you're doing a great job in securing the perimeter of your network, then you think, this attack will never reach my PLC, so I don't need to patch the attack, to patch the problem. But we've seen many times in latest incidents that this is not really the case. Attackers find their way through somehow, and you have to have appropriate mechanisms in different places in your OT environment. So patching is a problem. You can plan patching. You can say, I have, every month or every 6 months, you do your risk management, your risk assessment, and you say, I'll take the risk of not applying the patch for 3 or 4 months, because I assume the attackers, it will take them time to find their way in, because there's a window of opportunity, right? By the time the vulnerability is identified and the time you patch, there's a window of opportunity, but then the attackers have to find their way in during that window. And you're adding more layers of protection by having windows of opportunity. Another approach to ensure availability in your OT systems is redundancy, having more systems than needed and being able to hot swap between them. So when you need to patch one PLC, you switch the PLC out, you bring the redundant in, you do the security updates, whatever is needed, maintenance, regular maintenance too, and then you put it back, or you leave the redundant until you need another switch. So that's another solution. But of course, whenever you put something in the system, right, when you take something out, you put something in, you have to ensure proper testing, proper exhaustive pre-deployment testing, as also mentioned in the slide, to ensure that the PLC works as it should, that the new patch you installed does not affect the process, because it may change something, right? Typically, the vendors are very careful to ensure that anything they change in the PLC, in the systems, they actually ensure that it won't affect the behavior of the PLC, right? But if something changed in the protocol parsing, for example, you found a vulnerability in parsing Modbus packets, and then now the Modbus packets have extra delay in checking them because you don't want buffer overflows there, maybe there's some increased delay, right? So you have to also, in the OT side, you have to ensure that you do exhaustive testing before you apply the patch and you put the PLC back to the system. Moving on to risk management. So in the IT, the main purpose of information technology, as we saw in the first lecture of this class, is the use of computer to store, transmit, and process data or information. So the main task of IT is to manage data. So it's mostly about confidentiality. You may heard the triad: confidentiality, integrity, availability. In the IT world, confidentiality is the highest priority, and followed by integrity. Availability we already discussed before. Momentary downtime is not a major risk when you do your risk management. You have your business side restarting someone's computer momentarily. It's not a big risk to the day-to-day operation of the company. So the most impact you have is delay of business operations, right? But this is not something, for example, in the OT, a major risk would be loss of life or mechanical damage or damage of equipment or degraded production. So in the IT, you mostly care about data and you mostly care about confidentiality and also integrity. You want to ensure that your data is not corrupted in some way or another, either maliciously or accidentally. So you need backups in order to recover from potential problems or potential attacks, like lately we've been seeing a lot of ransomware. In the OT side, the main task is to control the physical world. So that's what an OT system does. So what you focus on is human safety. And then that's followed by the protection of the process, right? You have to ensure that humans are safe and there's no risk of injury or loss of life. And then you have to ensure your production proceeds as it should. So when you're discussing your risk management approaches, you have to put your objectives, and then the first objective will be human safety and then protection of the process. If we go back to the triad discussion, confidentiality doesn't seem to be such a priority in the OT. There's more discussion about availability, we saw before, to make sure that your process stays operational, but also integrity is probably equally important. There's discussion whether availability is more important than integrity, because integrity also is important. You don't want your process to still work, but not work properly. Maybe it's better for something not to work instead of malfunctioning throughout, right, and producing bad quality products in the output. For example, computers, when there's a memory error and you get, the blue screen of death that we see sometimes, it's the computer deciding not to continue because there's an error, and the error cannot be corrected. And since it cannot be corrected, it may propagate and damage more things than just stopping the computer there and ensuring that the error doesn't manifest further. So integrity and availability are very important in OT, and the order of the two, what is more priority, it's up to the individual entity risk management approach. So fault tolerance is essential in OT. You have to ensure you somehow tolerate errors, tolerate faults, redundant PLCs we saw before, or other ways to ensure fault tolerance. Momentary downtime is not acceptable. You cannot just turn off a PLC for a few seconds. Again, the risk management, you have to take into account all these things as your major risk impacts are non-compliance, environmental impacts, loss of life, equipment, or production. Another major difference connected to the risk management we were just discussing is physical effects. So as we just said in the IT devices do not have physical effects since they're mostly controlling and processing data or information. ICS devices, PLCs, operation station, DCS controllers are directly responsible for controlling physical processes. So in a way, the ICS can have very complex interaction with the physical processes, and it's very hard to understand if something happens in the controller or in the system, what will that effect be in the physical world. And you may be coming from different backgrounds. Some of you may be engineering experts, some of you may be cybersecurity experts, but everybody has to meet in the middle, right? The OT security has to be approached by both security experts and control experts to ensure that there's a proper discussion. We need to understand what would happen. You have a DOS attack on a PLC, right? How bad would this effect be on the process? It's different if we're talking about the power grid. It's different if we're talking about the desalination plant. It's difficult if we're talking about the chemical process. Every downtime, every window of downtime of the PLCs will have some different effect on the control side, on the process itself, and this cannot be understood without communication with experts in the control system and the particular physical domain. So there should be discussion when we approach security. We cannot be disconnected from the physical process experts. The discussion has to involve them, has to include them, and we have to ask and understand what would be the effect be if the controller misbehaves, right? What is the effect if the controller doesn't respond? Physical processes have inertia, for example, and the control expert may say it's better for the PLC not to respond because of inertia instead of the PLC misbehaving. So when you do security and you detect some kind of a malicious behavior, then maybe your acceptable action would be to disconnect the PLC
if your control expert guaranteed you, or actually gave you the information you need, that it's better that for the PLC not to be responding and let the process inertia take care of the rest, then you disconnect. If the process engineer said that the PLC has to respond one way or another because stalling is unacceptable, then you take that into account when approaching the security problem and finding solutions for that. And with this, we conclude the first part of discussing the differences between IT and OT security.